Finally, it is raining lava from Italy's Mount Etna. Increased volcanic activity has created a stunning spectacle atop Mount Etna, which is the tallest active volcano in Europe.
Located on the eastern coast of Sicily, Italy, Mount Etna stands tall as a colossal force of nature. However, the truly unique feature of this mountain is the marvel of its dynamic stature. The height fluctuates with each eruption, making it a constantly changing entity. This perpetual activity has rendered Mount Etna a fascinating subject for scientific inquiry, attracting researchers and volcanologists from around the world. So, what is really going on with Mount Etna? Join us as we explore the state of Mount Etna, revealing the urgent call by Sicily officials for a mass evacuation as eruption looms. The enigmatic Mount Etna. Nature has always had a way of creating wonders that draw curiosity and attention from around the world. Whether it's the breathtaking Grand Canyon in the United States, the stunning Ha Long Bay in Vietnam, or the surreal Salar de Uyuni in Bolivia, these sites have left the scientific community in awe, pondering how they managed to exist. Mount Etna, situated on the eastern side of Sicily in Italy, is no exception. With a history that spans over 500,000 years, making it older than any city or civilization known to man, this massive volcano stands at an impressive 8,030 feet tall. What's fascinating is that its height isn't always constant, changing with each eruption. Mount Etna's history is marked by countless eruptions, often causing destruction and damage, leaving the people with no choice than to build and rebuild. The 1669 eruption, for instance, wiped out several villages and even reached the city of Catania, reshaping the land and altering the coast. However, Mount Etna isn't just about destruction, it also creates new things. The soil around the volcano is incredibly fertile, perfect for growing grapes, olives, and other crops. Locals have a saying, "Etna gives and Etna takes," acknowledging the volcano's dual nature. But what makes Mount Etna so unique? Its origin dates back millions of years, resulting from the movements of tectonic plates. Sicily's location, where the African plate meets the Eurasian plate, creates intense underground activity. As the African plate goes under the Eurasian plate, it melts, producing magma that rises through cracks in the Earth's surface, erupting as lava and building up to form Mount Etna. This process has been ongoing for millions of years, creating a complex structure of hardened lava, ash, and volcanic rocks from numerous eruptions. One of the most fascinating aspects of Mount Etna is its frequent eruptions. Unlike some volcanoes that remain dormant for years, Etna is almost always active, thanks to the ongoing movement of the tectonic plates. When the pressure from the magma becomes too high, Etna erupts, either explosively or effusively, constantly changing the surrounding landscape. This constant activity makes Mount Etna a hotspot for scientific study, offering valuable insights into the Earth's geological processes. So, how are they going about it? A fascination for science. Mount Etna is a volcano of immense scientific importance, serving as a natural laboratory where researchers can study the intricacies of volcanic activity. By observing Etna's behavior, scientists gain valuable insights into the movement of magma beneath the Earth's surface, the mechanisms of eruptions, and the subsequent aftermath. A recent event, where Etna spewed forth hot lava, black smoke, and ash into the sky, even prompted the temporary closure of nearby Catania Airport. By analyzing such events, scientists can refine their understanding of volcanic processes and improve their ability to predict eruptions at other volcanoes worldwide, saving lives in the process. This has been anything but easy, as Mount Etna has proven itself to be somewhat tricky. To monitor Etna's activity, scientists employ a range of innovative tools, including seismographs, satellites, drones, and gas sensors. These instruments enable researchers to maintain a close watch on the volcano's behavior, tracking even the slightest changes. However, despite these advances, predicting the exact timing of the next eruption remains a challenging task. Throughout history, Mount Etna has inspired both wonder and fear, with a recorded history of eruptions dating back to around 1500 BC, although it is likely that the volcano was active long before that. The ancient Greeks and Romans, who lived in close proximity to Etna, were witnesses to its awe-inspiring power and documented its eruptions. The volcano's activity has unquestionably shaped the surrounding landscape and the lives of nearby communities. This leads us to the devastating eruption from nature's marvel. Mount Etna's most destructive moments. One of the most significant eruptions in Mount Etna's history occurred in 122 BC, causing catastrophic damage to Catania. The devastation was so severe that the Roman Senate exempted the city from taxes for 10 years to aid in its recovery, a testament to the enormity of the disaster. Fast forwarding to 1669, Etna experienced another massive eruption, commencing with earthquakes and the opening of a crack on the volcano's side, unleashing a stream of lava that ravaged several villages en route to Catania. Although the city's walls managed to divert the lava flow to some extent, considerable damage was still inflicted upon the surrounding area. This prolonged eruption, spanning several months, even extended the coastline as the lava reached the sea. These ancient events may seem like distant memories, but Mount Etna remains remarkably active. A notable example is the 1928 eruption, which obliterated the town of Mascali. The lava engulfed the town, leaving little untouched. However, from the ashes, a new Mascali emerged, thriving on agriculture and tourism. Strategically situated between the volcano's peak and the stunning coastal beaches, the town welcomes visitors throughout the year. In the historic center, one can admire the 20th century church of St. Leonardo and the small church of the Nunziatella, where the remains of an early Christian basilica, the oldest in the diocese, were discovered in 2012. Nearby, the hamlet of Sant'Antonino stands as the sole surviving testament to the 19th century Mascali, spared from the volcano's fury. As you ascend towards the mountain, the vineyards of Puntalazzo and Montegrano unfold, cultivating the unique grape variety that produces the renowned Nerello Mascalese wines. The area is also famous for its long green beans, known as U Mascalisi. The coastal region of Mascali boasts the picturesque beaches of Sant'Anna and Fondocello. The prompt response to the destruction by the Italian government, who proactively rebuilt Mascali in a new location, further away from Etna's reach, showcased the great length they went to preserve Mascali. This ongoing cycle of destruction and rebuilding around Mount Etna exemplifies the complex relationship between the volcano and the surrounding communities, showcasing both the challenges and benefits it presents. From 2002 to 2003, Mount Etna saw a big eruption that involved some really intense explosions and new cracks opening up along the sides of the volcano. The 2024 eruption of Mount Etna was a significant event, causing massive ash clouds that disrupted air travel and lava flows that threatened nearby towns. Fortunately, scientists, equipped with modern technology, closely monitored the situation, providing early warnings that helped safeguard local communities. The most recent notable event at Mount Etna occurred on August 4, 2024. On the evening of August 3rd, residents near the volcano noticed an increase in earthquakes and tremors, indicating a potential eruption. The National Institute of Geophysics and Volcanology in Catania vigilantly monitored the seismic activity, alerting the public to the likelihood of an imminent eruption. As the night progressed, the tremors intensified and became more frequent. By 3 a.m., the volcanic tremor energy had escalated from moderate to extremely high, signaling an unavoidable eruption. At 4 a.m. on August 4th, Mount Etna erupted, primarily from the Vagine crater on its southern side. Spectacular lava fountains reached heights of up to 4,900 feet, accompanied by a massive ash cloud that rose 10 kilometers into the sky and drifted southeast, blanketing nearby towns and villages in ash. The ashfall transformed the landscape, resembling a surreal winter scene with dark snow. The ash, composed of tiny volcanic rock particles, settled on buildings, vehicles, streets, and other surfaces, causing significant disruptions. The ashfall also posed health risks, contaminating water supplies, damaging crops, and potentially causing respiratory issues. local authorities advised residents to stay indoors and wear masks when venturing outside. Cleanup crews promptly began clearing ash from public spaces to restore normalcy. The damage didn't stop there, as the eruption predictably impacted air travel, prompting the INGV to issue a warning for airplanes due to the ash cloud's potential to damage engines and compromise flight safety. The local airport in Catania was forced to close temporarily, and flights were either canceled or rerouted to avoid the ash cloud. Mount Etna's recent eruptions demonstrate the volcano's unpredictability and how testing it can be living in close proximity to nature's gate of hell. How the 2024 eruption impacted Sicily. Fortunately, the airport staff and emergency teams performed an outstanding job, working tirelessly to clear the ash from the runways and ensure the safety of all passengers flying in and out. However, the eruption was far from over. Lava continued to flow from the Volcanic crater, slowly descending the slopes of Etna. Although the lava mercifully spared major towns, it did engulf some farms and damage roads and infrastructure. Local farmers were forced to watch helplessly as their fields and orchards were buried under the relentless lava flow. These agricultural areas are crucial to the local economy, making the situation particularly challenging. As the day progressed, the eruption gradually subsided. The volcanic tremors decreased to medium-high levels, indicating a slowdown in magma flow. The frequency of lava fountains diminished, and the massive ash cloud began to dissipate. Although the worst had passed, a significant amount of cleanup work remained. The community continued to work diligently to remove ash and assess damage, especially to the affected farms. Local authorities were busy formulating plans to support those most severely impacted by the eruption. The Civil Protection Department was actively engaged, ensuring public safety and establishing temporary shelters for those forced to leave their homes. Despite the feeling of an impending disaster that constantly surrounds it, Mount Etna is one of Sicily's premier tourist attractions, drawing thousands of visitors annually. The most popular route to the summit is via the road leading to the Sapienza Refuge ski area, located on the southern slope of the crater at an elevation of almost 2,000 meters. From the refuge, a cableway ascends to an elevation of 2,500 meters, providing access to the crater area at about 3,000 meters. The Ferrovia Circumetnea, also known as the Round Etna Railway, is a narrow-gauge railway constructed between 1889 and 1895. This 110-kilometer-long semicircular railway runs around the volcano, starting in Catania and ending in Riposto, 28 kilometers north of Catania. 2 ski resorts are situated on Etna, one at the Sapienza Refuge, featuring a chairlift and 3 ski lifts, and a smaller resort on the northern slope, at Piano Provenzana, near Lingua Glossa, with 3 lifts and a chairlift. Notably, the Sapienza Refuge was the finish point of Stage 9 of the 2011 Giro d'Italia and Stage 4 of the 2017 Giro, highlighting the mountain's significance in international sporting events. Well, despite the appeal, Mount Etna's display of power serves as a reminder that, despite nature's beauty and elegance, it also possesses the capacity to disrupt our lives. But during these difficult times, it's important to turn to our community, so together we can all overcome this adversity. Although the destruction has been painful, it hasn't been without its lessons. A learning site for others. Mount Etna, Europe's most frequently erupting volcano, is a hub for scientific inquiry, attracting researchers seeking first-hand knowledge of volcanic dynamics. Its regular bursts of activity and proximity to populated areas earn it a spot among the critical decade volcanoes, necessitating intense and continuous observation. Insights gained from studying Etna are crucial for forecasting future eruptions and devising strategies to safeguard nearby communities. Living near Mount Etna poses inherent risks, but understanding its patterns can significantly mitigate these risks. Scientists dedicated to studying Etna work tirelessly to predict its next eruption, enabling local officials to prepare, warn residents, and implement measures to protect people, infrastructure, and agriculture from potential destruction. Enhanced knowledge of Etna's eruption habits leads to improved safety plans and swift responses in emergencies. Moreover, each eruption presents a unique opportunity for scientists to study geological wonders up close. By examining ejected rocks, lava, and ash, researchers gain a deeper understanding of subterranean processes, shedding light on the Earth's formation and evolution. This research is vital for understanding the area's tectonic behavior, ultimately improving earthquake predictions and related geological forecasts. Mount Etna serves as a dynamic field laboratory for geologists and volcanologists, drawing scholars worldwide who seek to study its complex volcanic behaviors. The experience gained here is invaluable, equipping future geologists and volcanologists with the skills to tackle similar natural phenomena globally. Recent eruptions have provided valuable insights into magma movement beneath the volcano. By analyzing seismic data and erupted materials, researchers have discovered multiple magma chambers at varying depths, revealing the intricate interactions that influence eruption intensity and type. This knowledge is crucial for making more accurate eruption predictions, enabling scientists to provide timely warnings to protect local communities. By meticulously analyzing Mount Etna's recent explosive activities and more fluid lava flows, researchers have identified distinct patterns. These valuable insights facilitate predictions about the volcano's future behavior, allowing for swift warnings to be issued when necessary. A significant focus of recent studies has been the gases released by Mount Etna, including sulfur dioxide, carbon dioxide, and water vapor. Monitoring these gases not only helps gauge the volcano's current state of activity, but also plays a vital role in predicting imminent eruptions. Furthermore, understanding the effects of these gases on the environment and climate is essential for broader ecological and atmospheric studies, providing a more comprehensive understanding of the volcano's impact. As we examine the most recent eruption, the focus shifts to the methodologies employed by scientists to predict these events, highlighting the importance of ongoing research and monitoring. How scientists study Mount Etna. Observations of lava flows during recent eruptions provide essential data for researchers. By tracking the trajectory and flow dynamics of lava, scientists can understand the impact of variables like terrain slope and lava thickness on its movement. This information is crucial for creating detailed hazard maps that help protect communities from the path of flowing lava. In Sicily, scientists are collecting a vast amount of data to monitor moving magma inside Mount Etna, one of the most active volcanoes globally. With nearly 1 million people living on the volcano's flanks, accurate eruption predictions can be a matter of life and death. Advances in technology have revolutionized the monitoring of Mount Etna. A combination of satellite images, drone footage, and ground sensors now offers a comprehensive, real-time view of the volcano's activity. These tools deliver precise information on everything from subtle ground movements to changes in gas levels, enhancing our ability to monitor and respond quickly to signs of unrest. Mount Etna's continuous activity sparks the interest of scientists worldwide, fostering international collaboration. These partnerships are essential for deepening our understanding of volcanic processes and improving eruption prediction models. Sharing knowledge and technology benefits all involved in volcanic research and hazard management. Predicting the exact moment and nature of Mount Etna's eruptions remains challenging, but ongoing research and technological advancements have significantly boosted our ability to anticipate these events. By studying past eruptions and continuously monitoring the current situation, scientists can identify early signs of an eruption, such as increased seismic activity, noticeable changes in ground structure, and shifts in gas emissions. Seismic monitoring is a primary method used to predict eruptions. Seismographs installed around Mount Etna capture and analyze tremors that suggest magma movement underground. By examining the details of these earthquakes, experts can better forecast when an eruption is likely to occur. Tracking ground deformation is another crucial technique. As magma pushes toward the surface, it causes the ground above to bulge and crack. Using GPS and satellite technology, scientists measure these changes precisely to determine how much magma is building up and where it might break through. Measuring gas emissions is also vital, as rising magma releases gases that, if detected in increasing amounts, can indicate an approaching eruption. By continuously measuring these gases around the volcano, scientists can more accurately predict when and how Mount Etna will erupt next. Satellite technology is essential for monitoring Mount Etna, providing a full picture of the volcano's activity, especially in hard-to-reach areas. This satellite data is critical for watching volcanic eruptions unfold and forecasting future activity. The use of drones. The use of drones and remote sensing technology has revolutionized the way we monitor volcanoes like Mount Etna. Equipped with high-resolution cameras and various sensors, these drones fly over the volcano, capturing detailed images and collecting data on gas emissions and ground movements. This enables scientists to safely monitor Etna's activities from a distance, gathering precise information that would be challenging to obtain otherwise. All the data collected, from seismic activity and surface changes to gas emissions and satellite and drone observations, is processed through sophisticated computer models. These models simulate the volcano's behavior, illustrating how magma moves and leads to eruptions. By integrating real-time data with these simulations, researchers can make more accurate predictions about when Etna might erupt next. However, it's not just about advancing scientific knowledge, it's also about ensuring safety. The data collected from monitoring Mount Etna is used to keep local officials and communities informed about potential dangers. Early warning systems and emergency plans are in place to ensure people can quickly reach safety if an eruption appears imminent. Research on Mount Etna is ongoing, and scientists continually seek innovative ways to improve eruption predictions. Advancements in monitoring equipment, data analysis, and modeling are crucial for gaining a deeper understanding of the volcano's behavior. These innovations are vital for better predicting eruptions and protecting lives. As technology evolves, scientists will continue to refine their methods, ultimately enhancing our ability to anticipate and prepare for volcanic activity. These breakthroughs haven't stopped scientists from seeking other methods to further understand and monitor Etna's activities. Volcano monitoring at Mount Etna using fiber optic cables. To further enhance our understanding and prediction of volcanic events, a more comprehensive grasp of the diverse underground processes involved is essential. So, what's this new innovative approach and what's it about? Let's delve into that. Fiber optics is the technology used by internet services such as Verizon Fios Home Internet to transmit information as pulses of light through strands of fiber made of glass or plastic over long distances. Fiber optic broadband has historically been limited in where it is offered, though the United States' Department of Energy is evaluating the feasibility of expanding fiber optic networks. Optical fibers are about the diameter of a strand of human hair, and when bundled into a fiber optic cable, they're capable of transmitting more data over longer distances and faster than other mediums. It is this technology that provides homes and businesses with fiber optic internet, phone, and TV services. A fiber optic cable contains anywhere from a few to hundreds of optical fibers within a plastic casing. Also known as optic cables or optical fiber cables, they transfer data signals in the form of light and travel hundreds of miles, significantly faster than those used in traditional electrical cables. And because fiber optic cables are non-metallic, they are not affected by electromagnetic interference that can reduce speed of transmission. Fiber cables are also safer as they do not carry a current and therefore cannot generate a spark. A novel approach to detecting these subtle processes is the use of fiber optic cables as sensors. By analyzing the light backscattered in these cables when deformed by vibrations, researchers have successfully determined the volcanic signature of Mount Etna with unprecedented precision. An international team, led by Philippe Jousset from the German Research Center for Geosciences Potsdam and Gilda Currenti from the Italian Istituto Nazionale di Geofisica e Vulcanologia, reported this breakthrough in the journal Nature Communications. The method, known as distributed acoustic sensing, has proven capable of identifying seismoacoustic volcanic activity from a distance and mapping hidden near-surface volcanic structural features with high sensitivity and accuracy. This innovation is poised to revolutionize volcano monitoring and hazard assessment. Recent years have seen significant advancements in understanding physical processes preceding and during volcanic eruptions. However, conventional observation methods, such as seismometers, still struggle to detect subtle triggering mechanisms of volcanic phenomena. The limitations of measurement methods and unknown underground structures distorting signals hinder accurate detection and identification of all processes within the volcano. Nevertheless, knowledge of even weak activities is crucial for predicting and assessing the danger of volcanic eruptions, particularly at Mount Etna, Europe's largest, most active, and most visited volcano, with over 1 million people living on its flanks and in its immediate vicinity. Characterized by frequent explosive eruptions with lava emissions, Etna's volcanic activity demands precise monitoring and prediction. Test of a new measurement method on the volcano Etna in Sicily. Felipe Jusset from GFZ, Gilda Carenti from INGV, and their colleagues have investigated the suitability of fiber optic cables for measuring very weak seismic and volcanic activity. To achieve this, the team deployed a 1.3-kilometer-long fiber optic cable, approximately 20 centimeters deep, in a scoria layer on Mount Etna, about 2 kilometers from the summit craters. They measured the strain changes of the cable caused by various volcanic activities using the distributed acoustic sensing principle. DAS involves sending successive light pulses into an optical fiber via an interrogator using a laser. The light, partially backscattered by the fiber's natural imperfections, is then analyzed. When the fiber deforms or stretches due to tiny ground movements, acoustic waves, or temperature changes, the light's travel time changes. This enables detection and precise measurement of such events every meter along the fiber. Previous research has demonstrated the potential of DAS for recording earthquakes using fiber optic telephone lines. Since GFZ researchers showcased this in Iceland in 2018, seismic activity monitoring has been conducted in several locations worldwide, including the USA, Switzerland, and Japan. The technique has also been applied in other geoscience applications where ground motions or vibrations need to be measured. By harnessing the sensitivity of fiber optic cables, scientists can gain valuable insights into subtle volcanic processes, ultimately enhancing our understanding and prediction of volcanic events. The new fiber optic method is suitable for the analysis of volcanoes. Now, the researchers have successfully demonstrated the method's suitability for accurate analysis and monitoring of volcanoes. The cable, deployed in a scoria layer, detected strain changes associated with Etnaean volcanic activity, including volcanic explosions, small volcanic degassing, local volcano-tectonic earthquakes, and atmospheric phenomena like hail and thunderstorms, explains Philippe Jusset, lead author of the study and a scientist in the Geophysical Imaging of the Subsurface section at GFZ. The DAS strain rate measurements were validated with conventional sensors, geophones, broadband seismometers, and infrasonic sensors. The locally dense measurements, unachievable with other methodologies, enabled the detection and characterization of both volcanic explosions and non-linear interactions of the propagating acoustic wave with near-surface scoria deposits, triggering resonance phenomena in the subsurface. To quantify hidden subsurface structural features and detect volcanic events with accuracy, standard volcano seismology analysis, wave and strain propagation modeling tools, and techniques like wave field separation and reconstruction were applied. According to GFZ scientist Benjamin Schwartz, the spatial resolution offered by fiber optic strain measurements allows for the extraction and amplification of very small but important signals previously out of reach for quantitative analysis. Our study demonstrates that DAS, with its high sensitivity and accuracy, can efficiently monitor volcanic activity, Jusset summarizes. This contributes significantly to advancing our understanding of volcanic processes, and we believe this technique will become a standard for volcano monitoring in the years to come, Gilda Carenti anticipates. A special advantage of fiber optics is the ability to take the most accurate measurements possible even from great distances. Thanks to its long-distance probing capabilities, currently at least several tens of kilometers, an interrogator can be set up in a remote location, making fiber optic observations easier and safer than conventional sensor arrays, which require telemetry, on-site power supply, and regular maintenance. Fiber optic cables running from the volcano's summit to remote locations would provide unique opportunities to deepen our understanding of ground response, including estimation of path effects and aiming at a better understanding of the origin of volcanic phenomena, says Lotte Krauchik, also one of the cable diggers and spokesperson of the POF4 research program at Helmholtz. Additionally, the availability of fiber optic cable submarine infrastructure close to volcanic islands will greatly aid in studying otherwise largely inaccessible submarine magmatic processes. But beyond the innovative technology and scientific discoveries, Mount Etna's rich history and cultural heritage are woven with fascinating stories and legends that have evolved over centuries. A big volcano such as Etna has always inspired fear and respect. It does not sound strange, then, that the people keep on handing down myths and legends written by ancient men who tried to explain the frightening phenomena of the Earth. These tales have been passed down through generations, captivating the imagination of people around the world. They speak of ancient myths, mysterious forces, and unexplained phenomena surrounding Etna's frequent eruptions. One legend tells the story of the Greek god Hephaestus, who was said to have forged thunderbolts for Zeus in his underground workshop beneath Etna. According to myth, the volcano's eruptions were a result of Hephaestus's intense labor as he hammered away at the Earth's core. Another tale describes the giant Enceladus, who was imprisoned beneath Etna by the gods. His struggles to break free were said to cause the volcano's eruptions. But do you believe in these tales? Another myth is that Persephone liked to gather flowers on the lower slopes of Etna and to dance with the nymphs on the plain of Enna. When Hades abducted her, he opened a crevice in Mount Etna as an entrance to the underworld. Another myth that has been circulating is that the cattle of the sun grazed on the slopes of Mount Etna. According to legend, killing and eating some of these sacred animals brought destruction upon Odysseus's men. This myth is intriguingly linked to the town of Taormina, as its name may originate from the Greek word tauros, meaning bull. Furthermore, a nearby valley, aptly named the Valley of the Ox, is said to be a suitable grazing area, adding credence to this ancient tale. This captivating story has been passed down through the ages, weaving a rich tapestry of myth and history around the majestic Mount Etna. While scientists have made tremendous progress in understanding the natural processes driving Etna's activity, these legends and stories continue to inspire wonder and curiosity for those who believe in them. They invite us to consider the possibility that there may be more to the volcano's behavior than meets the eye. Could there be unknown forces at work, hidden beneath the surface, that even the most advanced scientific tools can't detect? The frequency and intensity of Etna's eruptions have led some to speculate about the possibility of a larger, more significant event on the horizon. While this is purely speculative, it is undeniable that the volcano's activity has captivated human imagination for centuries. As we continue to monitor and study Etna, we may uncover even more secrets about this natural wonder, and perhaps even shed light on the mysterious forces that have inspired so many legends and stories. Thanks for watching. See you in our next video.